Yo, 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 what it do, homie G? That was just for you, Blake. I know you like that one. Stop smirking. It's not funny. In this video, we're going to be talking about factoring polynomials. The first thing I want to talk about with you guys is there are kind of two special cases that you will see. These two special cases are right in front of your face. So one of these cases is the sum of cubes. So notice I have a to the third plus b to the third. So I have a is a cube because it's a to the third, a cubed, plus b cubed, so the sum of two cubes. This factors always and forever as a plus b times a squared minus ab plus b squared. The other case is difference of cubes. Notice these are very similar. So the difference here, that one is a plus, that one is a minus. So difference of cubes, they're subtracting because you're taking the difference. Also, notice these signs relate right there. Right there. It's the same sign. So if we have a sum of cubes, our first factor will be a plus b. If we have a difference of cubes, our first factor will be a minus b. Also notice, if this is a minus, this sign is a plus. If this is a plus, that sign is a minus, because everything else stays the same. A squared minus ab and b squared, a squared plus ab, b squared. So a squared, ab, b squared, a, b, minus, plus, plus, minus. Okay, so we're going to be messing around with those very first thing. But this is something that you're just going to have by memory. But you're going to hopefully be practicing this enough that you won't have to like work down and memorize it. But I would highly suggest you guys write this down like 4 or 5 times at least to help yourself remember this factoring case. There's nothing other than just like memorizing this that's going to help you do these problems. So you will see stuff like x cubed plus 8, and it'll just say factor. So you have to recognize, well, I have a cube, so maybe I can rewrite this as a cube. Well, we can because 8 is 2 cubed. So if I rewrite this as x cubed plus 2 cubed, then I have a sum of cubes. So what happens is in this case, our x is like our a, our 2 is like our b. So if I factor, I know if I have the sum, my first factor is going to be a plus b. So in this case, x plus 2. The second factor is a squared, so x squared, minus, because it's the different sign, minus ab. So a is x, b is 2. So 2x, and then plus b squared, well, b is 2, so plus 4. That's it. That's all the factoring we are looking for, because this will not factor any further. So really, this is like, if you don't know these, you're going to be in a lot of trouble. So make sure you guys write these down like 4, 5, 10, 12, however many times you need to make sure you have these memorized. If you don't, it's not going to do very well. Again, you'll see something like this, where it just says factor. And this one, it's even telling you it's cubes. So if we have a difference of cubes, this is like our a, this is like our b. So if I have a difference, I know I'm going to take a minus b, so x minus 2y in the first factor. Then I will have a squared, so x squared. Since this is a minus right here, this is going to be a plus right there. Then it's ab, so x times 2y, so 2xy, and then plus b squared, so plus 4y squared. That's it. That's how you factor it. So again, that is the special factoring case. Let's see if I can get it all on the same screen. Yeah, difference of cubes. So I have a cubed minus b cubed, x cubed minus 2y cubed. This case, x is our a, so anytime I have an a, I have an x in that place. Anytime I have a b, b was 2y, so anytime I have a b, I had 2y in that place. And that's really all that you're going to be learning. There's one other special factoring case, but we'll get into it in just a minute. It's not anything you have to memorize. You have to memorize these cubes. If you don't memorize these cubes, I can't stress it to you enough. You're going to be in some trouble. Come on, zoom in. Zoom in. I want to be able to see it. So close. That is ridiculous. Wow, that is pretty ridiculous. I wasn't expecting that. Okay. All right. So we have in this one, I notice that cubed. I notice I have a plus. So I can rewrite 27 as 3 to the third. So this is the same thing as saying 3a to the third. 8 is 2 to the third. So I have like an a and a b. Since it's a plus, I will have 3a plus 2. And then it's a squared, so 3a squared would be 9a squared because 3 times 3 is 9. Yeah. And then I know I'm going to have a minus right there. These two things multiplied by each other. So 6a, and then plus 2 squared, which is 4. So plus 4. That's it. That is factoring that. All right, we'll look at another. I'm going to do another with you guys. Blake, that sounded kind of like you. I'm just kidding. I love you, Blake. You're my boo. All right, factor. We have a cube. So probably this is a cube. It is a cube. Imagine that. So we have a cubed minus 27 is 3 to the third. So we can rewrite this as difference of cubes. So a minus 3, a squared or plus the opposite sign. These two things multiplied, so 3a plus 3 squared, which would be 9. Okay, that's really all there is to that stuff. Then with this unit, you'll start seeing some other factoring, but you've done this before. You actually had a test over it right before the midterm. Oh yes, and that was your favorite test of all. So with this, notice you have an x in all of your terms. Anytime you can take out a common factor, do it. So if I can divide out my x from all of these terms, because they have that in common, we put the x on the outside, and now I can factor x squared plus 2x minus 15, just like you did in Algebra 1, just like you did in geometry. It just keeps coming back because you love it so much. And you're going to do it in pre-cal again next year when you have me again. If you have me again, if you're unfortunate enough to have me again. So factoring, remember x and x. Since I'm multiplying to be negative 15, and I'm adding to be 2, difference between 3 and 5 is 2. So I probably have plus 5 and minus 3, such that when I multiply the outsides, I'll have 5x, and the insides minus 3x. 5 minus 3x is 2x, and I know 5 times negative 3 is negative 15. Don't forget, they add or subtract to be that number, and they multiply to be that number. The numbers I'm talking about right here are right there. So negative 3 and 5 add to be 2. Negative 3 times 5 multiplies to be negative 15. And factoring completely, that's it. That's all that we can do for that one. If you can get it down to linear factors, so what I mean by linear is like if I look at that factor, it's a line, it is x to the first power. That is as far as I can go. And make sure you guys are checking your answers on the worksheet. You will definitely know that that's as far as you can go. Factor completely again. That's all we're going to be doing. This is it. We just do the same thing the entire video. So factor completely. Here I have x squared. There's no common term that I can pull out from any of that, so I just have to factor this as I see. Oh. So numbers that multiply to be 12 are like 3 and 4, 6 and 2, 1 and 12. The ones that add to be 8, whoa, there it is, that add to be 8 are 2 and 6, so I must have plus 2 plus 6, so that 6 plus 2 is 8. 2 times 6 is 12, factored completely. Oh. Do it again. X squared minus 5x plus 6. So again, no common factor that I can pull out, so I must have an x and an x such that they multiply to be x squared. Positive 6, so I need two things that multiply to be 6 that add to be 5. Well, that could be like 3 and 2. Negative times a negative makes that a positive 6, and they will add together to be a negative 5. Factored completely. All right, moving on. This one's a little bit funky. It kind of smells weird. Because we have x to the fourth minus 5x squared. Don't freak out, because just like the last ones, we had x squared and minus 5x. When I multiplied those two terms together, they would make the x squared. The outside terms together, the x and the 2 and the 3 and the x, would add together to make a x to the first power. So same sort of idea here, especially if this exponent is half of that exponent. So what we can do is if we start off with x squared and x squared, I know they would add together with my outside and inside terms to be an x squared part. So this even factors just like the last one into something like that, because negative 3 times negative 2 is 6. Negative 2x squared and negative 3x squared will add to be negative 5x squared, and then x squared times x squared will be x to the fourth. If this were a difference of squares, we could factor it. If you really, really wanted to, you could say that this is x plus root 3 and x minus root 3 and x plus root 2 and x minus root 2. If you were in pre-AP, I would definitely want you to do something like that. But since they're not like perfect squares, you probably won't have to do that. So we'll just leave it in the quadratic factors like this. All right, I'll show you one that you can do that though. So like this problem right here, I don't know why I have that weird line going through it. He's so pretty. Hey, look at it. Yeah, yeah. Well, that's the back of my head. I'm sorry, I'm getting a little cuckoo. It's like 7 o'clock at night and I'm getting tired, old man. Old man. So same sort of difference, x to the fourth, 2x squared. So if I start out with x squared and x squared, now I need to multiply to be 24 and have a difference of 2 because that's a minus sign right there. So if I use 6 and 4, I want to have plus 6 minus 4, so that 6 minus 4 is positive 2. 6 times negative 4 is negative 24. So now also with this, notice we have a difference of squares right there, because this x squared, the same number times itself to get x squared is x, the same number times itself to get 4 is 2, so this part will factor even further. This x squared plus 6 is kind of stuck, so it'll create imaginaries, but we can factor x squared minus 4 into x plus 2 and x minus 2. I will expect you to do that. So what you're looking for there is if this is a perfect square, this is 2 times 2, whole numbers. This is a perfect square, x times x, whole numbers, and whole letters. They have a minus sign in the middle. That is a difference of squares. That is a special factor. In case you learned in Algebra 1, you did it again in geometry. You're doing it again now. Yeah, you even did it earlier. Whatever. Oh, stop. Just keep going. Just keep going. Stop ranting. Just show me how to do the work, man. All right, factor completely again. Same sort of idea. I'm trying to nail you guys on these x to the fourth to help you. So x squared and x squared, so that they would add to be an x squared in the middle. They multiply together to be x to the fourth. I must have to multiply to be 16. Notice it's a positive 16, so they're the same number. They both must be minus. So I can use minus 8 and minus 2. Neither of those are perfect, so I will leave my answer just like that. Beautiful. It's so pretty. Oh, he's using purple pen now. I like purple pen. All right. So here we have x to the fourth minus 10x squared plus 9. So again, x to the fourth, x squared times x squared will give us x to the fourth. They will add together with our outside and our inside terms to get x squared. So I must have, in order to multiply to be 9 and add to be 10, don't forget about the obvious ones, about 9 and 1. So now check this one out. 9 is a perfect square. It's 3 times 3. 3 times 3. 1 is a perfect square because it's 1 times 1. I know my variables are perfect squares, so these are both difference of squares. So x plus 3, x minus 3, and x plus 1, x minus 1. That is all factored out. That is factored completely. All right, the next kind of special case that we're going to be looking at is something like this. So it's kind of a pain in the butt when we have that x to the third. So we do something called factoring by grouping. So if we kind of look at these in individual segments. So if I were just to look at x to the third plus 2x squared, they have an x squared in common. So if I factor out x squared, I'm left with x plus 2. Then if I look at negative 3x minus 6, they have a negative 3 in common. If I factor that out, I end up with x plus 2. Huh. Now notice, out of both of these terms, so out of this term and this term, they have an x plus 2 in common. So what happens here is it's like we factor out x plus 2, and we are left with x squared minus 3. So again, we are still left with x squared minus 3. That would be factored completely for this one. Again, if this were a perfect difference of squares, it would go down further into x plus or minus stuff, just like we saw in this last problem up here. So here's where I usually get some questions about where did the second x plus 2 go? Let me rewrite this in a different way. If I change this to x squared times a minus 3 times a. So I'm calling a this x plus 2 part. A is x plus 2. It is that factor of x plus 2. Zoom out just a little bit. All right. So here, they both have an a in common. So what I'm doing is I'm factoring out the a such that I have that term on the outside. I have taken out my common factor. So essentially the same thing is happening. These are multiplying my x squared and my negative 3. So I am factoring out, I'm taking out that common factor that is multiplying both the x squared and the minus 3. That helps us factor tremendously. I'm going to do a few more of these guys. I'm going to do 3 of these guys with you, so don't feel like I'm going to be left you out hanging. But it's just like I'm taking out that common factor. This one's weird. This is kind of strange. So make sure you guys practice this one for sure. But it is super duper handy, especially when you get into upper level math like pre-cal and calculus. Uber handy, I promise you. All right, so again, we have x to the third minus 5x squared minus x plus 5. So I don't really see any special case. It's not like the difference of cubes or the sum of cubes. So if I look at these parts individually, and that part, then I can factor out an x squared from the first part, so that it's x minus 5. Now I'm going to see if I can make an x minus 5 term, just like we had 2x plus 2 terms. Well, I'm really close. Let me get in the right spot. I'm really close because this is negative x plus 5. So if I factor out that negative 1, this turns into positive x minus 5, so that these are both the same term, and I can factor out that same term. So I'm still left with x squared minus 1, so x squared minus 1. That x squared minus 1 is a difference of squares. So factoring completely this one would be x minus 5, x plus 1, and x minus 1. That is what I would expect to see. Please make sure you guys star, highlight, whatever questions you have. You will have questions, so please do not ignore those questions. If you need help on this, so like I said, it's a little bit weird, so come get some help from me. That's what I'm here for. That's what I love doing. I love you guys. I really do, I promise. So let me help you. All right, looking at another. This is 10x to the third minus 8x squared plus 25x minus 20. So again, I notice that there's no other special case other than maybe factoring by grouping. So if I try to take these two together, I can factor out a 2x squared from both of those terms, such that this is 5x minus 4. Now I'm going to see if I can make a 5x minus 4 out of those two. Well, if I factor out 5 plus 5 times 5x minus 4, hail, it has a common factor. It has the common factor of 5x minus 4. So if I factor out 5x minus 4, I'm left with 2x squared plus 5, which will not factor any further. So that would be the solution I expect to see. Factor completely again. We got 2 more. We're almost done. We're almost done. Thanks for hanging with me, guys. So again, 2x cubed plus 10x squared plus 3x plus 15. So if I take out and I factor by grouping, these two in common have a 2x squared. I'm still left with x plus 5. Now if I can make a x plus 5 term by taking something out here, well, it looks like I can factor out a 3 such that it's x plus 5. Now I have an x plus 5 term in common. These are in common with both of them, so if I factor that out, I have x plus 5 and 2x squared plus 3. Nothing else will factor any further. That's it. All right, last one. Oh, you did this one already. All right, so I have x cubed minus 8. So anytime I see only two terms and one of them is a cube, it makes me think about my either difference of cubes or sum of cubes. This one would be a difference because it has a minus sign in the middle. So I can rewrite 8 as 2 to the third. So this is really x to the third minus 2 to the third. So I have x minus 2 times the first thing squared plus different sign. These two things multiplied, so plus 2x minus plus, I'm sorry, plus, it's always plus, plus the second thing squared. Right, so that is our difference of cubes. First thing minus the second thing, first thing squared plus two things times each other plus the second thing squared. It wasn't white noise, it was my mouth. All right, hopefully this video was helpful for you guys. I love you guys, and I will see you soon. Shut up, Fridge. Nobody wants to hear it from you.